So the presentation that I've got is more of this high-level stuff. So I'm gonna kind of shoot through that and talk about some of the stuff that we're doing now, that we're doing that we're working towards getting out this year, some of the exciting new development. And then I'm gonna go back and give you guys some demos and talk through some states that do some tricky things, and talk about some of the new things that we've got in states for the next release of Salt. Okay. So as all of you know, we're kind of obsessed with speed at SaltStack. And so one of the things that we've recently put together, which is going to be highlighted in the next, or introduced in the next release, at least in beta form, is a new transport system. Salt itself was originally built on 0MQ. And 0MQ has served us quite well. It's a fantastic networking system. But the problem that we've run into with 0MQ happens at really large scale. And it happens when it comes around to a lot of aspects of predictability, and we run into problems where the network connections between minion and master aren't necessarily reliable. We've got a long-standing history of 0MQ hiccups there. And so in response to that, a lot of our customers came to us and said, especially our customers who are in situations of larger than 10,000 servers, came to us and said, we would like to see an alternative transport. And they initially came and said things naively like RabbitMQ, which can't handle those sorts of scale reliably, or at least I've never seen it come anywhere near that. we've got a number of people going, oh no. So we went back and we looked at what our options were and found that there weren't really many options, and decided to develop a system called RATE. RATE stands for the Reliable Asynchronous Event Transport. Now, what's being introduced in the next release of Salt with RATE is a UDP-based transport that's fully encrypted using Dan Bernstein's CurveCP encryption, which, because of many recent events, we're actually kind of glad we bet on that horse. But in our preliminary tests, it's running at the same speed as 0MQ. But in our larger scale tests, we're starting to see that it's able to outpace 0MQ when we start to work on larger scale. Also that it's so far been able to outpace the 0MQ when we're working in larger load environments, because we were able to architect it in a much more flexible way. So that's something that's exciting that's coming down the pipe. And on this slide, I talk about Salt SSH, because again, we try to make things in Salt modular. The idea is that Salt is able to solve whatever problem you need to solve inside of its space. That it's able to do things well beyond just what people generally think about Salt doing, because most people come back and they say, well, should I use Salt or Puppet or Chef? And they kind of miss out on the fact that if you've got a big Chef deployment or a big Puppet deployment, Salt can automate those very well. And that the communication bus in Salt in and of itself is a very powerful tool. So another thing that I like to go over is that when we look at the classical configuration management space, one of the arguments that comes up is, should configuration management be imperative or declarative? Have you guys heard this argument before? This is...
Yeah.
Okay, I've got 40% nods. Okay. And a very smug-looking, bearded fellow over here. And this man who's always been smug, since he was born smug. Okay. So primarily the difference is that when you're working with a declarative system, you declare what everything should look like, and it doesn't necessarily matter what order it executes in, because you've declared your system. But in an imperative system, you define everything as a series of steps which you're going to take for the deployment. Now, what we did inside of Salt version 0.17 is that we introduced an ordering layer in Salt that made sure that everything was executed in the order, or evaluated in the order in which it was defined. And then the declarative system took over and overrode the flat ordering that was defined inside of a file. Which means that Salt would always execute in the order in which it appears in the files, but you also have all of the power of the declarative systems in line as well. And then we look at systems like Chef, which are fundamentally imperative. They just run until they hit their first failure and then they bail. And so we've got systems inside of Salt that can allow you to run config management in Salt in a fully imperative way so that it bails at the first failure. Or we have systems that can go, so you can go fully declarative, or you can do a little bit of half and half. Now the big benefit of having both is that it always executes in the same order, it always executes in a finite order, and it always executes in a predictable order. Which means that the setup of that system is entirely predictable. You're not going, and you have a complete assurance of a cookie cutter deployment, which is a problem with which a certain other declarative config management system is known to have. What was that, Stuart?
If you don't want to say it, I will say that Chef is less than predictable and Puppet even more so.
Yeah, we always run in the same freaking order. And have a ton of tools around that.
Chef always runs in the same order. It's just really surprising what that order is.
Another thing that I want to mention is that the declarative system inside of Salt is ridiculously powerful. So the declarative system inside of Salt has the two basic components that you generally have in a declarative system, which is one that you say that you don't run this component, you require another component before you run this component. And the other one is that if this other component makes a change, then do a little extra work. So for instance, if a service is reliant upon a package to be installed or a config file, then if that config file changes, restart the service. But inside of Salt, we've got a couple other requisites in place, as we call them. One of them is called the Prereq. The Prereq is rather spiffy because actually got a grin. I've never tried spiffy before. I might do that again. The Prereq requisite's really spiffy because it allows you to say, to embed predictable behavior where you're able to say, if I'm about to change something on the system, then do this task before I change that thing on the system. Which allows you to say, if I'm about to deploy code, then maybe contact the load balancer and tell them, while I'm deploying code, take me out of rotation. Do you want to say something, Hartz?
Yeah, and how does that differ from just a plain require?
How is that different from a plain require?
Yeah,
Okay.
I mean, because I'm starting to use requires, so.
The command plus like 10 times.
Command plus, thank you. It's booted into Mac OS here, it's embarrassing. Okay, so the question is how do those differ? So, let's see, I've got some SLS files in here. All right, okay, so here's an interesting.
Does it need to be bigger?
Thank you, Colton. Okay, so this SLS file is how I automatically deploy the latest version of Salt out to the servers in this test environment so I could just be up to date with the latest commit in Git. But we're able to illustrate in a very succinct way what's going on. So if we come up here to the top, when we say include, we're including some other Salt formulas in here, so that if we ever run this, we're going to be setting up Git and installing Python requests. And then we've got some simple routines. So this one, for instance, is just executing a command from the command line by saying command run, and then the name is the command which we're going to execute, and only run it if this command returns true. But then we get into the requires, as Hartz is saying. So this one here says require package get. Now this means that we're not going to try to set up the latest Git checkout of Salt until we've made sure that the Git package has been installed, and we make sure that that happens up here inside of a different SLS file. So that's a basic require. All it says is don't run this until this has successfully run, and if this fails, then don't run this. Okay?
So
Now,
that will change the order in the low state, correct?
that changes the order in the runtime. You're diving right into low state.
Yeah, sorry.
We're not going to have time to go over state layers in here.
It might.
He's like in the... yeah, if I've got to stall till 9 till the CoreOS guys show up. If you want compiler details. Okay, and then the next requisite to mention is this watch thing. Now the watch requisite says, actually I'll talk about it down here, this one's a little more straightforward. The watch requisite says, do all those things that we did with the require requisite, but then if this thing that we're watching makes any changes, then run an extra routine that's defined for service running. In the case of services, the extra routine is to restart or reload that service. Okay? So watch allows you to say, if this Git routine that we were just looking at actually updates Git, then restart the salt minion. Okay? Now the question is how does prereq differ from require? So that's require. Now let's say we've got a prereq. I'll do it like this. Okay, so we've got HTTPD. All right. So let's say that we wanted to do something if before that Apache config file ever changed. You can think of it as a code deployment because I don't want to write out a code deployment right now. I'm trying to do a presentation. And I didn't think this question would arise, but it did. So I'm completely unprepared, which is something that, you know, Hartz back there does. Okay. All right. So this prereq says, if and only if we're going to update this config file, then run this command. Now that means that every time this config file is about to be updated, we're going to execute this command to shut down Apache. And then if we come up here, you don't actually need the spaces between the groups there, it just looks nicer. Okay. So, since I was saying that this is going to be evaluated in a finite order, I can tell you exactly what's going to happen inside of the runtime. It's going to evaluate everything from top down, and every time it hits a requisite, it's going to change what it does. So the first thing it does is it's going to say, HTTPD, is the package installed? If it isn't, it installs the package. The next thing it does is say, okay, now I'm evaluating this service running routine, and it says there's a requisite there, which is a watch. So it says, okay, before I can run this watch, I need to make sure that this config file, or run this service, I need to make sure this config file is in place. Okay, so it goes to the config file next. It doesn't actually try to start the service. It hops forward to the config file. The config file says, do I have any requisites? And the config file says, yes. I have a soft requisite on this other guy, because I can't run before this guy predicts if I'm going to run in the future. And so then it punts over to this guy, at which point he runs this guy in test mode or no-op mode to say, are you going to make changes when you actually run? If it is going to make changes when it actually runs, then it runs this command, unravels to this guy, makes the changes here, and then executes the service. But so the prereq, as you can see, made sure that, or checked to see if this was going to make changes. Does that answer your question, Hearts?
Yes.
Okay. Is anyone else now thoroughly confused? Good. They're either lying or you follow me. All right, now there's two more requisites that we just introduced that are coming in the next release that I'm excited about for a couple reasons. One is that it allows you to create some pretty interesting requisite tree traversals so that you can completely change the direction of your config management routine midstream. And two, because I was really surprised at the fact that they seriously took like 8 lines of code to get in. But those requisites are the on-fail and on-changes requisites. So we could do something like, what's that command? You know, some weird Apache thing. I guess that's not weird, but you know what I mean. Okay. So this new requisite, the on-fail requisite, says that if the Apache service fails to start, and only if the Apache service fails to start, then try something else. Does that make sense? Pretty straightforward. And it would make sure that the Apache service would try and start before ever evaluating down here. And then the other new requisite is called on-changes. And it's kind of like the watch that we were just talking about, but it's a little different. Because the watch runs 2 routines, on-changes just runs 1. But on-changes says, only run this guy here if the thing that we're looking at for on-changes changes something. Now that on-changes is useful because you're able to say, okay, in the situation where we have had to update the firewall, maybe we want to be careful and run an @ command to just fall back just in case. And so that can easily be embedded into the sequence to say whenever changes happen to the firewall. Okay? So when we talk about declarative, that's where we're at. Okay. Now, one thing that I want to highlight really quickly is where we're putting a lot of our effort right now. We've got a lot of our customers and users who have come back to us and said that they really like how Salt's remote execution systems work, and they want to do a lot more with them than just manage the configuration of their servers. And so we introduced a system called SaltVert recently, and we're working on a Salt LXC and Salt Docker integration pieces. Now, the idea here, or rather the original idea of Salt, was to create a system like this. When I originally developed Salt, the idea was let's create a remote execution bus that's fast enough to gather information about an infrastructure, and then based on that information we can make decisions about how we're going to be deploying virtual machines in a cloud. And so the first piece of one of the first things I did once I got Salt working was I wrote this piece on top of it called Butter. And Butter is still up on my personal GitHub account. It doesn't work anymore. I wouldn't recommend using it by any means. But Butter was able to, from the command line, manage a very lightweight KVM cloud. You know, for the most part. It hiccuped occasionally. But that was the original intent of Salt. But then we more or less went off in the direction of configuration management because there was a lot of excitement around configuration management, and we did a very good job of making it. And so we more recently came back to this concept. And so there's a piece inside of Salt now called SaltVert. SaltVert allows you to very, very easily set up a cloud. It's able to go out and communicate with your hypervisors and tell it to spin up KVM virtual machines. It's also able to seed those virtual machines with Salt keys, so that when those virtual machines come up, they get pre-authenticated back with the Salt master, so you can spin them up, and you have direct access to them over Salt. Since it's built directly into the config management system, you can do full chain deployments, where what you're effectively doing is able to say, spin up a virtual machine. Once that virtual machine comes up, it's directly tied into Salt, so it can configure itself and add itself into your deployment, and you didn't have to, build a system that did all that stuff. Now, we're putting a lot more work into SaltVert this year to really shine it up, add a lot of features and functionality to it, and we're also about to present the new Salt LXC interface, and that's basically the same thing, but you're able to work with LXC containers. And so do the things that you do with containers. Spin up a fresh container and start it so it runs like a fully fledged or fully bootstrapped virtual machine, or you can spin up a container and just tell it to execute a single application in said container. This is also one of the things that we've run into with a lot of people who are coming back to us and saying that they want to deploy Docker, is that they're very excited about deploying containers where they've got a full network stack and a full network bridge, and they're not doing some of the port mapping things quite yet that Docker is doing. But with that said, we've also got integrations that we're coming out with directly with Docker. So again, the idea being that Salt can easily manage all of the Docker instances or Linux containers or virtual machines without having to do something like set up all of OpenStack. The actual deployment and setup of SaltVert takes minutes. The SLS files that are needed for it inside of to deploy it with Salt's own config management system amount to something in the realm of 50 lines. It's trivial. Okay. So I mean, this is more or less a highlight of a bunch of the different things that I've talked about thus far. The idea that Salt's able to bring together and automate virtually everything that's inside of a data center. A lot of the work that we're working on now has to do with automating network devices. So we're in the middle of a deal with Cisco where they're going to ship Cisco switches with Salt minions on them, which is rather exciting and was surprisingly easy because they said, so you're written in Python? Yeah. Well, we ship with Python 2.7 on our switches anyway. We'll just chuck you on there.
Disabled by default?
Only turned on if the customer requests it.
Yeah.
We're not forcing everybody with Cisco switches to use Salt.
Just the scary idea that there's
Yeah.
my Cisco switch is trying to find the server folder. Boot it up.
Okay. But also the fact that we're working really hard on all of this virtual machine stuff. A lot of the idea of Salt is that you go into a lot of these deployments with big clouds, and there are a number of situations where deploying a full stack, OpenStack cloud, or VMware cloud, or you know what I mean, one of those, makes a lot of sense for a company. But we found that a very, very large percentage of our users, and we feel the majority of the people out there, they don't need to deploy all of the bits and pieces of an OpenStack cloud or a VMware cloud. They just want something that manages their freaking virtual machines. And so that's a lot of the focus that we're based on at this point, is saying here's a cloud environment that you can have up, running, and functional in an afternoon at worst, and be able to just start deploying VMs. Now the last thing is etc. D that I wanted to talk about, and that's something that is coming in the next release of SaltStack, or rather etcd support. And so if we come over here to Salt's documentation, okay, we've got rather extensive support in for CoreOS's etcd system. Now, some of the main hallmarks or big benefits of CoreOS, and when they get here, they can articulate them better than me, I'm sure. Or rather, I would hope. Some of the main benefits is the idea of being able to keep all of your configuration information in a central location where you've got this central source of configuration truth. And so what we've put inside of Salt is the ability to embed the gathering of information from etcd directly inside of all of Salt's interfaces. Which means that if you've got an etcd system out there maintaining all this configuration data, all of that configuration data can be grabbed directly from within Salt and applied directly. And it can be grabbed from Salt from within a template inside of a file that you're setting down on a system, or it can be used to grab the entire contents of a file and lay it down on a system, or it can be used to grab raw information that is directly interpreted via Salt.
Can be used to manage minion keys?
Sorry?
Minion keys?
Not yet. We haven't modularized the key authentication backend system quite yet. Or rather, it is modularized now, but it's been like a week.
I'll give you some Cafe Rio if you...
You want me to modularize that system like this tonight, huh?
Yeah.
I might not have time. I gotta give some presentations and like talk to people.
Okay, tomorrow.
So one of the first presentations I gave on Salt back in 2011 at the Salt Lake Linux Users Group. No, it was the Python Linux Users Group, this one. And I was showing them Salt's config management in its extremely early form. and they said, oh, those YAML files are cool. That'd be cool if you could write them in pure Python. And so we could before the meeting was done. I just don't have that kind of flexibility anymore. And full modularity systems are a little heavier. It takes a little while to modularize that stuff. Okay. But etcd, using the etcd execution module in Salt, you can do direct lookups and embed those throughout all of your systems. You can hook etcd into also into Salt's pillar system, so that you can say that components inside of etcd are going to be abstracted via Salt's pillar system as configuration values as well. So that is something that we are rather excited about. And the guy who wrote that is gone today already. He had to go home. And that was Joseph. There was another piece I'm forgetting. Pillar, oh, and the returner. So you can store all of your job return information inside of etcd. Okay. Let's see, do I have anything else to like yammer about? One more thing is that we've added a lot of extra interfaces inside of Salt that help you test your deployments. And we are in the process of adding a few more. So for instance, Salt tests, every time Salt starts a service, it double checks that the service started. Every time Salt installs a package, it double checks that that package was installed. And same with files and all these other things. But there's a couple interfaces that Salt isn't able to check yet that we're going to be releasing fairly soon. And that's the ability to check from a remote location to make sure that your web app that got deployed looks the right way. Or hit a database from another location and double check that the schema's lined up correctly. Things of that nature, or rather remote checks. Now based on the fact that this used to be Cafe Rio's office, I assume that he knows how to not burn the place down.
So I'm assuming you saw that then?
That this used to be the...
No, the flame.
Oh, well, it's hard to miss. It's fire. I'm a guy. Fire!
You're all excessively big today. I accidentally dipped the tip of the lighter in the petroleum jelly reference.
All right. So the food is here, is now incredibly obvious. So I'm going to stop yammering. Did you have a question?
I do, if I could talk to you after food.
Sure. I'm not going anywhere.
He sleeps here.
I'll sleep here.
I sleep in my corner.
The phase of the company in which I had to sleep at the office regularly has passed. I'm rather excited about that. Okay, does anybody have any questions before I release you for food? That's the easiest way to get out of questions, by the way. Does anybody have any questions?
Could you take a couple minutes to do an in-depth explanation of high state versus low state?
Sure, I'll go over that as soon as everybody gets to start eating. All right. So let's hit the lights.